I'm from Germany and I'm a mechanical engineer by training. I came to Zurich in 2021 for my master's studies. And I think I was highly influenced by the pandemic. I switched my interest from sustainable energy technologies more to medical research and especially biomechanics, and later on in the field of spine biomechanics. In the course of my master's, especially my master thesis, I focused on global sagittal alignment and related spinal loads and the variability, alignment and loads. And we tried to apply this in a healthy and asymptomatic cohort as well as in pathological cases, and try to understand the patterns and also mechanical complications in that sense and how biomechanics modulate that. And then after my master's, I kind of continued my work in the lab as a PhD student, then shifting my focus partially from, let's say, the big picture of global alignment and biomechanics more to intervertebral disc, load transfer, and especially load transfer in degenerative cases. And this is basically what we apply in the METASTRA project. We are developing a finite element model of the intervertebral disc as a function of degeneration to basically give more physiological and subject-specific boundary conditions to the metastatic vertebra to predict the risk of fracture in silico. Maybe this is obvious, but for me it's really the interdisciplinary communication that is outstanding and where I learn the most from. We need to really learn how to phrase our questions right, to ask the right questions, but also to put ourselves into each other's shoes and really understand each other's needs and perspectives. It goes in a multitude of directions. The experimentalists talking to the In-Silico modelers, the basic researchers talking to clinicians, caretakers. On top of that, I think what's really important is to also be very transparent with your level of expertise, especially in such a big consortium. I think it's very important to be transparent about your level of expertise in which areas and where you maybe need some assistance or lack experience, because we have so much knowledge on board that we can really benefit from a clear understanding communications and therefore grow as a consortium by really aligning each partner's strength to come up with some bigger, great project. And I think that's, for me, the biggest intake that I take out of this project, besides from our technical developments. I think in the field of basic science and especially spine biomechanics, there's an extensive research body over the last decades or even more, and really incredible models that have been developed with all sorts of levels of difficulties, let's say. But I think there's still this huge burden in really applying in-silico models, especially in a clinical setting. I feel like a lot of potential is not translated into clinical practice. And I think with the METASTRA project, we have this great opportunity because of this holistic or interdisciplinary consortium with so many levels of expertise. We have data management, regulatory experts, AI, clinicians, modelers, experimentalists, and a bunch more, that we really have this big aim to put this into clinical practice. More broadly, I really think that this project has the opportunity to really showcase how in-silico modeling can support surgeons in clinical practice in really tailoring patient-specific intervention strategies to, as I said, biomechanical realities. And I really hope that with this approach we can reduce the incidence of under and over treatment of metastatic cases or patients, and therefore really improve the quality of lives of patients that actually suffer from primary cancer or secondary tumors, and improve the quality of life and the quality of care, essentially.